Okay, the permutation combination, lecture number 4. We are doing case number 4 as well. So case number 4 is complicated seating arrangement. Now, with the name of the case, you need to understand that we are working upon the arrangement more. So let's just work through the example. Arrange 3 people in a row of 7 chairs. In the row of 7 chairs without any restriction. Now, as simple as that, what we need to understand is that we will be selecting only 3 chairs. So when you're selecting 3 chairs out of 7, it's similar to the alphabet case that was case number 1. But in that case, you already knew that you had 7 alphabets. But here you have chairs, and normally chairs are empty until and unless you don't make sure you place the people in those chairs and you tell them to sit down. But at the moment, what you need to do is you have 7 chairs. You are not told that they are filled or empty, but obviously if they are not filled, we'll consider them empty. So what the question has said, arrange 3 people in a row of 7 chairs. That means 7 chairs are there. So what we're going to do is we're going to pick what? 7C3. That means we will select 3 chairs. 7C3 means that we are placing 3 people in those particular 3 chairs. But when we have placed those 3 people, obviously there would be other options of making them sit as well. So the other options will be obviously changing their positions. When the changing their position will take place, it will take place as 3 factorial. So 7C3 into 3 factorial. The answer is 210. There's another way of attempting this question. You can always write down, since you need to select 3 chairs. For the first chair, you have option of 7 chairs. So 7C1, to make sure that your first person sits down, you have option of how many chairs? 7 chairs. Then obviously when one person is down on the seat, then obviously you are left behind with 6 chairs. So that should be 6C1, making sure the second person sits down. For that, it should be 6C1. And for the third person, obviously when two people are already seated, now you are remaining with how many chairs? You are remaining with 5 chairs. And you need to make sure that one person sits down in one of the 5 chairs. So this should be what? 5C1. So this should be 7 into 6 into 5, which will be equal to 210 as well. So this was the first part of case 4, that is complicated seating arrangement. Let's go with the second part of the second example question. Find the number of ways of seating a family of 3 members together. Family has men, woman, and child. Find the number of ways of seating a family of 3 members together. Family has men, woman, and child on 7 chairs. So that means we need to find out number of ways of making sure that how the 3 people will sit on the 3 chairs out of 7 chairs. So particularly what does this mean is that you have to understand the particular concept behind that. Now the question says together. The question says together. So what do we have is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I can place together. My together box can be here. 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 And together box can be here as well. That means I need to understand that the together box can have men, woman, child, men, woman, child, men, woman, child, men, woman, child, men, woman, child. In this particular way, what I need to understand is that in this way, your three, putting down three members and knowing that all the other chairs are empty, all the other chairs are empty, what I can have is 3 factorial for each option. 3 factorial, 3 factorial, and 3 factorial. I can have 3 factorial for each option. So what we can do is, either I can have 3 factorial into what? 5. That means there would be 30 ways. There can be 30 ways. That means each time what I'm doing is I've just placed the box at the first point, at the second point, third, fourth, and fifth. Or there's another option of dealing with this. The other option is, let's say, making sure that we have a box of women, men, and child, right? And we know this will contain 3 factorial of placing, positioning men, woman, child together in 3 different seats. How many seats do we have? 1, 2, 3, 4. We are left with 4 more seats. But obviously these seats are empty. So even if I place it anywhere around the corner, their position will not matter because all the seats are empty. But in this seat, what I know is there are how many gaps of putting down the block? There are 5 different gaps of putting down the block between the chairs. This is your chair, 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 and chair. Let's say chair because this is also your chair, and chair. How many chairs do we have? We have 4 different chairs that are left. Now putting down the block in the gap, how many gaps do we have? We have 5 different gaps. So putting down block, so this should be 5C1. Putting down block in one of the gap, 5C1 into your 3 factorial of the block. So 5C1 is again 5 into what? 6, which means 30 ways of dealing with arranging men, women, and child together in the block of 7 empty chairs. That means obviously when making sure that 3 people sit in, they will occupy the chairs and they can have 3 factorial down the corner. Whereas the other thing would be 5C1 putting that block in one particular gap. So you can work through both ways, either through the gap method or making sure that you have what? Different ways and then multiplying it with different ways. Or how many ways do we have? We have 1, 2, 3, 4, 5 ways. So 3 factorial into 5 different ways. You can always add them as well. 3 factorial plus 3 factorial plus 3 factorial plus 3 factorial plus 3 factorial. That even will give you your 30 as your answer for this. So your particular answer for this part is 30 ways. Case 4, another example. Still, we need to arrange 3 people in a row of chairs, 7 chairs, adjust the family in such that the way that they are together and child sits in between. Now, child is restricted. When child is restricted, we know that there are 4 empty chairs. So obviously, when the 4 empty chairs are there, we will not be using 4 factorial, since obviously they are all empty. Considering how many gaps do we have? 1, 2, 3, 4, and 5. So we use 5C1. And since we have a block of 3 chairs, men, child, and woman, child is fixed. But men and women can replace the position of having 2 factorial. So 5 factorial and 2 factorial will be used, which means 5 into what? 2. The answer is 10 ways of having the child in between men and women. Now, since we are working on case number 5, it says application of arrangement. Now, 5 books of Dan, 4 books of John, and 3 books of Charles are given. Let's say that number 1, arrange these books without any restriction. Now we need to just to arrange these books. When we are arranging these books, we know that 5 plus 4 is 9, 9 plus 3 is 12. So we have 12 books. So there should be 12 factorial. 12 factorial is 479001600. So this should be what? 12 factorial for the arrangement of 12 books. Then part 2, if it says books by John are kept together. So when the together word is used, we must think about block method. How many books of John we have? We have 4 books of John. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If we just look at this, let's say we have a block of 4 books and these 4 books will be together. Each book is basically separate from each other. Each book is separate from each other because all the titles of the book will be different. So that means we can have 4 factorial for the book inside the block. We can have 4 factorial for the book inside the block. But considering the fact that we have how many books left? 1, 2, 3, 4, 5, 6, 7, 8, and 9 is the block. That means all these books and the block will be arranged with each other. So which means 4 factorial for the books inside the block and 9 factorial for the remaining 8 books and the block together. So this particularly means that the answer is 8709120. Then we have is, let's go with the same case. Let's go with the same case. This should be books by each author are kept together. Books by each author are kept. There are 3 different authors. So obviously we'll make sure we have 3 different blocks. So 5, 1, 2, 3, 4, 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that means we have a block of 5 books. We have block of 4 books. We have block of how many books? 3 books. To make sure that these blocks are arranged, we will use 4 factorial for the, we'll use 5 factorial for the first block. Then we will use 4 factorial for the second block. We'll use 3 factorial for the third block. Then obviously we need to arrange the blocks as well. So 3 factorial for the arrangement of the block that will be there. So that means the entire thing will be rotate 5 factorial for the Dan books, 4 factorial for the John books, 3 factorial for the Charles book, and 3 factorial for the movement of the block. So this particularly will mean that the answer is 103680 for the movement of books when they are kept together by each author. All the books of Charles must be separated from each other. Charles had 3 books, right? So if the total books were 12, separating 3 books, that means now you're left with 9 books. So if you're left with 9 books, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there should be 9 factorial for the 9 books movement. In these 9 books, you need to understand that you have 10 gaps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you need to separate what Charlie's books. So Charlie's books have to be kept in these gaps so that they are separated. So to keep the first book of Charlie's, it should be 10C1. To keep the second book of Charlie's, it should be 9C1. And then it should be 8C1. Because once the first book is kept, then your gaps are left 9. When the second book is also kept, then the gap are left is 8. So this should be 2, 7, 2, 6, 1, 2, 7, 3, 6, 0. There's another way of doing it. This should be 9 factorial for the movement of the block, for the movement of the books. This can also be 10C3 into 3 factorial. You will end up having the same answer, that is 261, 273, 600 when the Charlie's books are kept separated.